Section 2.2, Slope and Rate of Change, and Section 2.3, Graphing Lines. First, we're going to start with slope, and the most common recollection of what slope is rise over run. And what that means also is the vertical change, because when you rise you move up and down, and run, because when you usually run you're running side to side, which is also the same as when we're the change in y, take one y coordinate minus the other over the change in the x. And the important thing to remember when you're doing this is that above and below each other should always be ordered pairs, so make sure you don't mix up your x's and your y's, and make sure you remember that the change in the y always goes on top. So when we're talking about slope, there's basically four kinds of slope. There's basically uphill or positive slopes, negative or a downhill slope, a horizontal line which has a zero slope, and a vertical line which has an undefined slope. And the reason I put a vertical line with undefined slope in red is because a vertical line is the only kind of line that will not be a function. So without graphing, tell if the line through the given points rises, falls, is horizontal, or vertical. So in other words, I don't want you to graph this, meaning I also don't want you to visualize how it will be. I want you to use the slope formula. So the change in the y will be -5 minus a -2. Make sure you're subtracting those coordinates. Over the change in the x, since we took the -5 first, we must take the -3 first when we're taking the x's. So -3 minus 6. So the slope, double negative is a positive, we get -3 over -9. So we get a slope of a positive 1/3. Don't forget that your negatives cancel each other out. Therefore, since this is a positive slope, the line will rise from left to right. Again, looking at this next example, I want you to use the slope formula. So the change in the y, and it doesn't matter which coordinate we take first. Last when we took the first coordinate, let's take this coordinate. So 1 minus 3 is the change in y over -5 minus -5. So we'll see that we get -2 over 0. If you tried to put this in your calculator will give you an error, which means this line is undefined slope, and an undefined slope is going to be a vertical line. Next we have parallel and perpendicular lines. Well, the first thing that should come to mind if I were to ask you what are parallel lines is that you would tell me that they never intersect. In order for two lines to never intersect, they must rise at the same rate that they run at. In other words, they have to have the same slope. So the slope of line 1 equals the slope of line 2 means they're parallel lines. Perpendicular lines, if I were to ask you what perpendicular lines are, the first definition that would probably come to mind is that they intersect at a 90-degree or right angle. Well, in order for this to happen, their slopes must be opposite reciprocals of each other. In other words, if I have a slope of 5, the perpendicular, and I'm going to use this symbol for perpendicular slope would be -1/5. So opposite, positive to negative, and reciprocal, you're just going to flip the number. So tell whether the lines are parallel, perpendicular, or neither. Again, I don't want you to visualize these. As I did before, I am going to model how I want you to show your work. So the first thing that you're going to need to do is find the slope of the first line. So the change in the y, 8 minus 2, over the change in the x, I must take the 5 first, minus 7. When I simplify this, 8 minus 2 is 6, over -2, so I can simplify this slope as -3. Now I need to find the slope of the second line. So again, using the slope formula and showing my work, -2 minus a -1, taking the y coordinates, -7 minus a -4. My double negative is positive, and I get my slope is -1 over -3, which simplifies to a positive 1/3. So now I'm going to look at these two slopes, since -3 and +1/3 are opposite reciprocals, these lines are perpendicular. So rate of change, in the same way with slope, we were looking at the change in the y to the change in the x, so one change in relation to the other one. A rate of change when we're dealing with applications or word problems is how much one quantity changes on average relative to the change in another quantity. So this is no different than slope. But for example, when we're dealing with word problems, we're going to deal with things like miles per hour. How do miles change per hours? Or degrees per day? Or cost per gallon when you're filling up your car, how is that changing? Or dollars per hour for what you're earning when you have a job. So a rate of change problem might look like this. Mrs. Vincent was 5'1" back at the start of 2nd grade. By the 5th grade, she grew to be 5 foot 5 inches tall. Find the average rate of change in Mrs. Vincent's height over time. So it's telling us right here that we're looking for the height over time. Then determine how tall she would be by grade 10. So keep in mind, if we're dealing with change in height over time, when we're looking at finding the slope, we're finding the change in y over the change in x. So this tells us how to set up our ordered pairs. We're going to take time, will be our x-coordinate, and height will be our y-coordinate. So my two ordered pairs, when I was in 2nd grade, I was 5 feet 1 inches tall. Well, we need to change 5 feet 1 inches tall into inches. 5 feet is 60 inches, and one more will be 61. And in 5th grade, 5 feet 5 inches, so 65 inches tall. And these are our two ordered pairs. And now we're going to simply find the slope of those. So go ahead and do that, please. So you should have gotten a slope of 4 over 3. So 4 inches in 3 years, or as a rate, as a unit rate, this is 4/3 inches per year. Now, determine how tall she would be by the 2nd grade. So we could write an equation for this, but let's just think about this logically. 10th grade is 5 years after 5th grade. So how much did she grow in 5 years? 4/3 inches per year times 5 years will tell us that she grew 6 2/3 inches in that 5 years. Well, in 5th grade, she was 65 inches tall, plus another 6 2/3 inches makes her 71 2/3 inches tall. If we convert that into feet, we get 5 feet, 11 2/3 inches in 10th grade. As a refresher on how to graph lines, generally we're going to have our equations in the form of y equals mx plus b, and so this is exactly why last chapter when we were solving equations for y, that I wanted you to put them in the form of the number times x plus that constant, because now all our equations will be in this form of y equals mx plus b. And previously, hopefully you've noticed that I have used m to represent the slope. So the coefficient, the number part of in front of the x in all these equations will be the slope of the line. And also remember that this form of an equation is called slope-intercept form. And the reason it's called slope-intercept form is because by looking at the equation, we have our slope, and this value, our b, is always going to be our y-intercept. So that's going to be our starting point, remember. We're going to plot our y-intercept, and then from that point, we're going to move the rise over run that corresponds to our slope. So let's do a few of these examples. If we have y equals -2x, so the coefficient of our x is -2. That's our slope. And you'll notice that we're not adding anything on. But don't forget that 0, so our b, our y-intercept, is 0. So we're going to start at the point 0, 0, And our slope, if we were to write this as a fraction, would be negative 2 over 1. So now we have a rise over a run. So we can go down 2, and over 1. To graph another point, we can go down 2 again and over 1. We could also go in the opposite direction as long as we move the negative in only one direction. So we could go up 2 and back 1, up 2 and back 1. And I would like you to draw points at this point in our class that go through the graph that you have. So don't just graph 2 points and slap the line in them. If we look at our next example, y equals x minus 1, well, what's the coefficient of our x term? Remember, if there's not a number there, then it's understood that it's 1, which we can write as 1 over 1. And then our b, mx plus b, well, we're adding a negative 1, so our b is negative 1. So we're going to start on the y-axis at negative 1, and then our slope is up 1 over 1. So we're going to move up 1 over 1 until we get to the edge of our graph paper in both directions. And then we're going to connect them. And we've graphed our line. For the next 3 examples, the next 2 examples, I would like you to do on your own. Again, identifying what your m is and identifying what your b is, and graphing until you reach the edge of the graph paper. And we've graphed that line. And I'll go ahead and graph this one. Remember that the negative can go in either the numerator or denominator, so we can rise negative 2 or we can run negative 2. Just remember that if you rise and run negative, then you'll be going positive. And now the last example. There's actually 2 ways to do this one. So to begin with, I would like you to solve it for y and go ahead and graph it that way. So you should have gotten y equals 2/3 x plus 4, and now go ahead and graph that. Now when you have an equation that's written in standard form like this, you could also graph it using the intercepts, keeping in mind that any point that intersects the x-axis has some value x, because we move left or right, and then we move up and down, nothing. And then the same with the y-intercept. The y-intercept will have, we won't move side to side at all, so the x-coordinate will be 0, and then we will have some number, and this will be the y-intercept. So if we were to plug 0 in for the y and solve this for x, we would get negative 6. And if we were to plug 0 in for the x another time and solve this for y, we would get y is 4. And if we look at those, 1, 2, 3, 4, 5, we have our negative 6, 0, and our 4, 0, 4, and we would graph the same line. So this is another way you could graph a line if it's given to you in standard form. So remembering this little phrase, Hoy-Vux, can sometimes help you in graphing lines. And what they mean, that it's an acronym, and the Hoy stands for horizontal line, means it's going to have a 0 slope, and the equation is going to be y equals. So in other words, if you come across any one of these 3 cases, if I have an equation that's y equals and there's no x in it, I know automatically it's going to be a horizontal line. Similarly, Vux stands for a vertical line, an undefined slope, and the equation is x equals. So if you ever have just x equals and there is no y coordinate, it's going to be a vertical line. So for example, if I had y equals 3, to graph this, I would go up to where y equals 3, and I know it's a horizontal line, so I can just graph that one point and draw a horizontal line. The same with this. Where is x negative 1? X is negative 1 there, and I know that it's going to be a vertical line, so I can just draw in a vertical line. And finally, an application. The value of a copier x years after it was purchased can be modeled by this equation, y equals 4,000 minus 600x. And so what is the y-intercept? Well, if we were to write this in the form of mx plus b, negative 600x minus 4,000, plus 4,000, What's the y-intercept? Well, the y-intercept is 4,000. And what's the slope? Negative 600. So what do you suppose this represents? Well, if I look at the number of years, if I have the copier for 0 years, the y-intercept represents the value of the copier when it was new. It's 0 years old, so obviously that's what the value is. What is the slope? So what would happen to something that you own? Well, obviously it's going down in value. So the negative 600 represents the amount that it goes down or depreciates per year. So if you have any questions, make sure you bring them to class, and please make sure that you go back and do the notes check. And we'll see you in class tomorrow.